Hey Teletizens, back with me again, Ajigotama Putrada. I am your lecturer for parallel and distributed systems. This is our 8th meeting about parallel systems introduction, and this is the last video. In the last video, we will discuss about Amdahl's law, the second equation. Stay tuned. So, why do we need a second equation? So there are several reasons. First, the first one. Problem is the first one is it assumes that the parallel part of the parallel part of the program disappears. It doesn't disappear, it is just divided into smaller pieces. So how do we calculate the smaller pieces? We need to take in account or we need to calculate also not only the part that disappears, but we need to calculate first the number of cores. And so comes the second equation. So behold, so the second law is a little bit different. The speed up now is 1 divided by the parallel part, which is still the same, but it is divided by the number of cores, and it is added with the serial part. So P is parallel portion, S is serial portion, and N here is the number of cores. First, I'll give you an example. So here basically we have the same example as before. We have a program and 50% of the program is parallelable, but here we have an additional information. There are 2 cores involved. So now with the second equation, what is the speed up? And first we will write down the equation. Speed up equals 1 per P per N plus S. And here S is the serial portion, but here we don't have the serial portion in the problem, so we have to use our logics. So if 50% of the program is parallelable, it means that the rest is serial. So the equation is S equals 1 minus P, or S equals 1 minus 50%, and 50% is 0.5, so 1 minus 0.5 is also 50%. So here the equation becomes 1 minus P, 50%, divided by N, which is 2, and it is added with the serial part, which is also 50%. And 50% divided by 2 is 25%, and 25% added with 50% is 75%. So 1 minus 75%, and 75% is 3 by 4. And so this will equal 4 per 3, which is 1.333. So the speed up is 1.333. And that's if before we calculated that the speed up is 2, it is actually 1.333. In the second equation. So that's the reality brought to you by the second equation. So that concludes our video, the seventh video. In the seventh video, we have discussed about the second equation of Amdahl's law, and this also concludes our meeting. So in the eighth meeting, we have successfully discussed about the introduction to parallel systems. So now you know a little about parallel systems, and in the next meeting we will discuss more about parallel systems. There are many to learn about parallel systems. Thank you for your attention. I'll meet you in the next video.